Okay, the next unit we want to look at in this course is basic units and unit conversions. When we talk about numbers and quantities in science, the key thing to think about is that we always want to be using quantities and not numbers. Quantities are different from numbers in that quantities contain a unit that give us a reference point to the unit, the value that is being used. Those units are so important because they tell us the difference between a number, just the number that means nothing, and something that has a lot of value. Just a good example is if I told you to move away from your computer right now and walk 10. If you walked 10, that wouldn't tell you anything. Somebody might go 10 steps, somebody might go 10 miles, somebody might go 10 feet. Without that unit, numbers have no value. The units that we use in science are known as the International System of Units, or the SI units. It comes from the French name. And you've probably heard these referred to mostly as the metric system. We're one of the only countries in the world that doesn't use this as our base system, so you've got to learn the basic metric system, unlike your counterparts in other countries. The basic metric system units are listed in this table. You have mass, which is in kilograms. You'll notice mass is the only base unit, the kilogram here, that has a prefix in front of it. All the rest are single individual units without the prefix. Length, the meter. Time, the second. Temperature, degrees Kelvin. And amount of substance, the mole. The units that are going to be most important to us to begin with here are kilograms, meters, and seconds. But Kelvin will be important if we talk about temperature, and mole, very important in chemistry when we talk about amount of substance. All other units that we deal with are known as derived units. Derived units are units that come from the fundamental base units that we work from. So if you're multiplying, dividing different things together, you come up with a derived unit. Volume is a great example of a derived unit. Volume, length times width times height. So one derived version of the unit is meters cubed. Length in meters, width in meters, height in meters, meters cubed. Now there are other units for volume, liters and such, but those are all based on that derived unit that comes from length. Other examples of this might be density. Density, mass divided by volume, so kilograms divided by liters is a derived unit that comes even from another derived unit in volume. Prefixes are incredibly important when we talk about units because the fundamental units are not always the most convenient size that we want to use for something in class or something in the laboratory. So prefixes are very important because they allow us to adjust the units by powers of 10. You're used to the prefixes, you use these in middle school and previous science classes. But we want to go through the major prefixes starting at our base unit. Our base unit falls right here in between this gap. So this is our base unit here, larger than the base unit going up, smaller than the base unit going down. So let's start at our base unit, work our way to the small units, and then we'll work our way back up to the large units. The small units, deci, 1/10 the size. There are 10 decimeters in 1 meter. Centi, 1/100th the size. Easy way to remember that, think of cents in the U.S. money system. There are 100 cents in a dollar. Well, think of centi. Centi, there are 100 in the base units, 100 centimeters in a meter. Milli, 1,000 times smaller. So there are 1,000 millimeters in a meter, or 0.001 meters is a millimeter. Then you go 1,000 times larger. So in each of these gaps, this is a difference of 10. So this is 10 times smaller, 10 times smaller, or really 1/10 the size. 1/10 the size here. Now we're looking at 1/1000th the size. Once again, that would be 1/1000th. And this would be 1/1000th. So when you start dealing with these very small units, micro for 1/1,000,000th of the base unit, 1 million micrometers in a meter. Nano, 1 billion nanometers in a meter. And pico, 1 trillion picometers in a meter. These really small, micro, nano, and pico, become very important in chemistry when we're dealing with very, very small things. If you're going the other direction, you get 10 times larger. Deca, Da is the prefix. Hecto, H is the prefix, 100 times larger. The main one that we really like to think of, though, is kilo. So when you're knowing these units, you should have memorized kilo. You don't really have to worry about memorizing hecto and deca. Kilo, 1,000 times larger. Then you start to get into the really big units, mega, giga, and tera. Now, where you've probably seen these is a real-world example. Think about your computers. Computers, megabytes, gigabytes. Now we're talking in computer terms a lot these days of terabytes. The original computers started with the unit of the byte. The first computers that came into homes were in kilobytes. Now you're used to your iPhone having a gigabyte memory. Your iPod can store thousands of songs, and because memory is so cheap for computers, we now have all these technology that stores huge amounts of memory. And you'll commonly see people who buy terabyte hard drives because terabyte, 1 trillion times larger than the individual byte. There are 1,000 gigabytes in a terabyte. There are 1,000 megabytes in a gigabyte. So if you're working your way up, kilo, 1,001, mega, 1,000,000 for the base unit, giga, 1,000,000,000, tera, 1,000,000,000,000. So people who bought a terabyte hard drive have 1,000 gigabytes. Now you're starting to see the next one that actually comes above this, known as peta, which is one with 15 zeros. And that, if you think of Google processes 20 petabytes of data in a given day, is a statistic I saw recently. Quantities are very important. You must always use units. Leaving units off means that it's just a number and is pretty much not worth anything to us. So we always have to include units. Always put units on your tests and quizzes, your homework, any problems that you are solving in this class. When we use prefixes for measurement, since prefixes represent powers of 10, it is relatively simple to convert from one to another. Type of measurement must be consistent. You cannot go from meters to grams. You cannot go from moles to seconds. You've got to be in the same type unit, but you can use a prefix to go from meters to millimeters and vice versa. So here's some common examples. We have 74.3 millimeters, and we want to convert that to centimeters. So we would need to know what the basic conversion is between milli and centi. Centi's 100 times smaller, milli's 1,000 times smaller. So I know that 1 centimeter is equal to 10 millimeters. So I'm going to take 74.3 and divide by 10, and I would get 7.43 centimeters. The next one we want to look at is 18,300 kilometers to meters. The base conversion here, there are 1,000 meters per kilometer. Easiest way if you want to write this out to make sure you're doing it correctly, write the original number. We want to divide by kilometers. We want to get meters. So we'll do 1,000 over 1. 18,300 times 1,000, and we get 18,300,000 meters. Next one, kilograms to milligrams. Now here we're going from a unit 1,000 times larger than grams to a unit 1,000 times smaller. I know there 1 kilogram is 1,000 grams, and I know 1 gram is 1,000 milligrams. We're going to end up with a much larger number. We need to be multiplying. So 4.51 times 0.451 times 1,000 and then times 1,000 again. I end up with the final answer, 451,000 milligrams. One easy way to check to make sure you're doing this correctly is to think about the final answer. Milligrams, there should be a lot more milligrams than kilograms because milligrams is a smaller unit. So my answer should be larger in quantity than my original number. The last one, 1.56 milliseconds to seconds. There are 1,000 milliseconds in 1 second. I need to divide by the 1,000 milliseconds to get seconds. So if I were to write this out like I did the second problem, 1.56 milliseconds, 1 second for every 1,000 milliseconds, 1.56 divided by 1,000, I get a final answer, 0.00156 seconds. You also probably learned at some point the King-Henry method. The King-Henry method will work for these kind of problems, but it does not work once you get above kilo or below milli. If you get into the micro, nano, pico version of the prefixes or the mega, tera, giga section of the prefixes, the King-Henry method will not be as effective.